Hello everyone and welcome to my McTuts tutorial channel. And here I'm going to explain about the instantaneous center under kinematics of machine subject. And here we are going to understand about what do you mean by exactly instantaneous center, and what is the use and what are the different types of instantaneous centers are there related to the mechanisms which are used to make machines which works for a particular purpose. So let us start the discussion for the instantaneous center. So here I have given a basic definition, that is, it is defined as a center of rotation or oscillation which changes from one instant to another instant. So related to particular link of a mechanism. So when it is under rotation and oscillation, so it can have a center. So that center goes on changing during its oscillations or rotation whenever transmission of relative motion takes place during the working of the mechanism. And how exactly it is going to change, how we can understand that the center of the rotation or oscillation is going to change from one instant to another instant, that we can understand by considering a simple example. Here I'm taking a link here, this is a link consider, and to this link I have taken a center. So here I'm assuming that with respect to this center, this link is going to rotate. So I would like to give the center name as I, and I am showing the rotation direction. So when it rotates through a particular angle with respect to the center I, so I'm assuming the position has been changed to this one. So in this rotation, what happened? There is no change in the center location, but actually, what do you mean by instantaneous center? That center has to change from one instant to another instant. So if you consider this is the one instant and this is the final instant in this particular duration, so there should be some change in the instantaneous center, but there is no change in this center. So when it goes when it changes means here, so if you consider the displacement as well. Okay, so this link has rotated through a particular angle and then it has displaced to a particular distance. So when it is displaced, then automatically the center point also changes. So in this location, that means, sorry, in this condition, the instantaneous center has satisfied its definition. So that is only it has to change from one instant to another instant. So what we can understand exactly what the instantaneous center means, the instantaneous center of a particular link uh, changes its location whenever the link is under the combined effect of rotation and the displacement. That means here during the movement of this link, when it is taken in a particular mechanism, so some movement takes place for this link during the movement of all the links with respect to the fixed one. So during that position, if the link is under the combined effect of this rotation and as well as translation, then the instantaneous center changes. So that is only the basic thing. That means here the link is having instantaneous center means that link has to be uh, under the combined effect of rotation and uh, translation. Then only the instantaneous center changes. Okay, and what is the next thing we can say means, so I told you under the combined effect of rotation and translation, the center of the rotation changes. Okay, and the next we consider one more example. So I'm considering a four bar mechanism. So four bar mechanism means it consists of four links are connected together with a revolute joint, which will have a rotational effect with respect to another link. So this is the four bar mechanism I'm considering. So in this mechanism, how the motion transmission takes place means, uh, so before that I am giving the names to the links. Okay, then I would like to represent the rotation of the second link. Here whatever the shortest link is there in the mechanism, that can be called as a crank. So that crank will have a complete rotation. So during the rotation of this crank, all the links will move in relation to with each other with one fixed link. Here one link one has to be fixed. So with respect to that, this crank rotates and then these three will be oscillating. Okay, so which link is particularly going to have that instantaneous center which satisfies exact definition means here the third link. Okay, so during the rotation, this third link will have oscillations and as well as displacement. Okay, because it has the two revolutes, and these two revolute joints are not fixed in location. Okay, so that is why this third link will exactly satisfy the instantaneous center condition. So if you consider the instantaneous center can be located like this, so how we can locate the instantaneous center also we'll discuss in the next slides. Okay, so this is the instantaneous center which is going to vary during the transmission of relative motion in between the all links. Okay, so what I told here again, during the rotation of the link 2, the link 3 oscillates, so the instantaneous center shown in the figure changes its position. Okay, so during the rotation of this one, this 3 will oscillate like this and like this. Okay, so automatically this I also changes its position. That means rotation happens and the displacement also happens. So that is going to vary, that instantaneous center position changes. So that we can understand about the instantaneous center. And the next the terms related to the instantaneous center. What are the important terms related to the instantaneous center? That means some technical terms we should know about the instantaneous center. So what are the important terms that instantaneous center is going to have? Means one is the space centroid and second one is the body centroid. Okay, these are all only knowledge purpose. These are all given based upon the center point, based upon the change in the center point location. First, we try to see what is space centroid. Here, the space centroid means here centroid is the locus. So, space centroid exactly related to the instantaneous center means it is the locus of instantaneous center when the link is under the combined effect of rotation and the translation. That means here, so whenever the link is under the combined effect of rotation and translation, the center aut- automatically changes its location. Okay, so during that location change, if we trace the instantaneous center point movement, so whatever the curve we get, so that curve is only called as a space centroid. So we'll try to take one example here. So I'm considering one link which is having the velocity directions like this, and here I'm assuming the instantaneous center location, the first in at first instant, and when it has changed to next location during the rotation and translation, so I1 has changed to I2. And here again I have shown these two lines with the two different directions. Means here from the link end points the instantaneous setter will maintain one distance and I2 location will change in a different distance. That means these two distances will not be equal whenever it is under the combined effect of rotation and translation. So like this, during the entire transmission or entire movement of the of the link in a mechanism, if we trace the instantaneous center location, we'll get one curve. So by joining these I1 and I2, I can show one curve. This curve is only called as here space centroid. Okay. And next, similarly, what do you mean by body centroid? We try to see what is body centroid. Body centroid is also a locus of instantaneous center, and here it is with respect to the link. So why we are mentioning it is the locus of instantaneous center with respect to the link means here. So whatever the distances just now we have discussed in the space centroid, those distances will be changing. But here in body centroid, the distance will become constant. So that means by considering the constant distance to the endpoints of the link, we need to trace the instantaneous center point location. Then we'll get another curve which is called as your body centroid. So in the next sentence I have given as in body centroid, distance of the center at a particular instant is taken as a constant and the locus is traced. Okay, that is the condition here. So same example I'm considering the same link with velocity directions during the rotation and translation combined effect. So C1 is the first instant location, and in the second instant this distance we need to make constant. So that is why I have represented with the same color, red color. So when by making these two distances, I can assume the radius of rotation as constant, then the point will be changed to the C2. So likewise, if you trace number of instantaneous centers location during the rotation and translation by keeping the distance of the instantaneous center with respect to the link as constant, we'll get one more curve. Okay, so that curve is only called as your body centered. Here, one more condition we can consider, that the space centered curve and the body centered curve will be like two rollers rolling on each other. Okay, so the curves will be opposite to each other. Will get, okay. So that kind of the situation we can compare for the body centered and space centered. Next, we go for the next term. Sorry, next not next thing, that is the classification of instantaneous centers. So again, there are different types of the instantaneous centers. Uh, Rather than giving different names, all the points are taken as instantaneous center during the rotation of the link with respect to a particular one. And to differentiate the condition where they are going to take place in the mechanism, so different types we have considered. So what are the different types of instantaneous centers we can have? Means there are three types. One is fixed instantaneous center, and second one is permanent instantaneous center, and the third one is neither fixed nor permanent instantaneous center. Okay, these three are considered only for our convenient, rather than getting confused about the different centers of the rotation. So all the centers are given with a name as instantaneous center with some extended name, that is a fixed one, permanent one, and neither fixed nor permanent. So how we can understand these three means here? Here I would like to define the first one, which is fixed instantaneous center. So the definition I wrote it as, it is that instantaneous center which is fixed in position, and these centers are located on the fixed link of the mechanism. That means here during the movement of the links, the instantaneous centers will not be changed at all. So those centers will be at a location wherever they are placed in every situation. So that is why those centers are called as your fixed instantaneous centers. So for that, we try to take one example here. The four bar mechanism I have taken. So link one is fixed. So here fixed instantaneous center means the center points should be also fixed. Here you can see two revolute joints at the two ends of the link 1. So for link 2, this joint will become a center of rotation. For link 4, this joint become a center of rotation. So these two centers of rotation are considered as instantaneous center. So in that, what is the particular type of instantaneous center? Means fixed instantaneous centers. So these centers will not be changing their position during the working of this 4-bar mechanism. Got it? Next we go for the, so here I am giving the names also. There is I12 and I14. Joint between 1 and 2, I12, and joint between 1 and 4, the center is considered as I14. So these are the names we can give for the fixed instantaneous center. So I12 and I14 are two fixed instantaneous centers in the 4-bar mechanism. Okay. So the points, revolute joint points related to the fixed link are the fixed instantaneous centers that we need to understand here. And the next thing, permanent instantaneous center. So here it is defined as a center which is permanent but changes its location during the working of mechanism. So the joints, that means whatever the joint points we are considering as a center, those joints are permanent, but they'll be changing in position. Okay, so how practically we can see means here the same 4 by mechanism we can consider here. Wherever you can see the revolute joint in between 2 and 3, this is one center we can consider. The joint in between 3 and 4, this we can consider as one more instantaneous center. So during the rotation of this crank, that is the second link, these two centers are going to be changed. That means here the names we can give as I23, the joint between 2 and 3, and I34, the joint between 3 and 4. So these two I23 and I34 will change the position during the rotation of the crank. During the rotation of the crank, that means during the transmission of the motion through it from 2 to 4. So that is why these two center points are considered as permanent instantaneous center, not fixed, but permanent. Okay, permanent, but they change their location. Okay, so I2, 3, and 3 for our permanent instantaneous centers here. And next, neither fixed nor permanent instantaneous center. So neither fixed nor permanent means this will exactly satisfy the instantaneous center definition. So it is defined as instantaneous. It is defined as a center which is away from the mechanism and changes its position every instant. The same 4 bar mechanism we have considered, and if you try to locate the instantaneous centers, I13 is one instantaneous center, and I24 is one instantaneous center, which we can consider them as neither fixed nor permanent. Okay, so these two centers are going to change their location, so they are not fixed. And these two centers are away from the mechanism. They are not on the mechanism where they are not on the joints, so that is why these are also not permanent. So that is why these two centers can be considered as neither fixed nor permanent instantaneous center. Okay, so that is about the instantaneous center and the terms related to instantaneous center and the classification of the instantaneous centers. So what is the use of these instantaneous centers means? I told you already, we can find out the velocity of a particular link by knowing the velocity of any one of the number of links given in the mechanism. By knowing one thing, we can find out the uh, other things of the remaining links in a mechanism. That means by knowing the velocity of one link, the remaining velocities of links can be determined by locating all these instantaneous centers. And how to locate all these instantaneous centers, we'll discuss in the next video. So up to now, this is about instantaneous center, and I hope you understood about the instantaneous center. And if you still have any doubts related to this topic, instantaneous center, you can feel free to contact me through a comment section, and you can email me also. In the description, I'll provide my mail ID, so you can send your doubts to my mail ID also. And once again, thanks for watching. Thank you all.